Hello, so today we are going to do this problem called spiral matrix. So the problem says we get an m by n matrix and we want to return all elements of the matrix in spiral order. Okay, so what this means is basically we are going to go this way, left to right, and then up, down, and then right to left, and then, yeah, so it just keep going like that. Okay, so I think we can just try to simulate it. So how can we solve this? So basically, we need to go. Maybe we can do a for loop with 4 iterations, where for instructions or for things, and so those are from start row to end row. Sorry, the first one is for row left to right, and that will be start column to end column. And then after that we will go for first row. Okay, for column. So here start from 0, and here start from last column, right? And this would be up to down, which means we will need to do start row to end row, start row plus 1, right? Because we already start row already included. Okay, and then the third piece would be to do the right to left one, the last column. So for end row, actually end row here, start row, instead of doing this, and this would be for end column. And then here decrement end column, and here we need to increment start row, and here for end row right to left, and then we will need to do end row minus 1 because end row already included. And then we'll need to go to start row. And then here we need to decrement end row. And now we need to do first row for start column, sorry, for the first column, down to up. Basically would be end row. So we already decremented end row here, so we don't need to do anything. We don't need to exclude it there. End row to start row, we already incremented it, so we don't need to worry about it there. And then we need to decrement start column. Should we increment it? Sorry. Yeah. I guess here, so end row, that will be here. yes, one thing is the non-symmetry here is a little bit bothering me. So how can we, is this correct? So for the last one, we'll need to do the first column down to up, but since we already decremented end row, we don't need to worry about it. Here it's because we already incremented start row here. So do we need to do this? I don't think we need to do this here, because so from start row to end to the rightmost one, we increment start row, right? And so we don't need to do this +1 because it's already incremented. Do we need it here? We already incremented, so end column up to down. So we go from start row, which is the second one here, to the end row. And then we decrement end column. And now here, actually, this is wrong. But we need to start from end column to start column. And do we need to do end column -1? We don't, because we already decremented. Yeah, so it was a good idea to check this. To start column. And now we'll decrement end row. Yeah, I think this is good. Okay. So now let's try to do this. So what would be our for loop? That's a good question. So a for loop can be just while there are rows and columns. Rows or columns, right? So we need start row, we need end row, which would be 0, and then length of matrix -1. And then we need start column, and then end column, and that would be, so that would be end column 0, and then length of matrix 0 -1. One thing we need to check is if the size is at least 1. Yes, okay. And now we need to apply our rules here. And so while I will first do something here, rows, to store the number of rows and the number of columns. So that will be length of matrix and length of the first one. And we can replace this with rows, replace this with columns. And so while start row is smaller than rows, and or start, we will need to handle the case where one of them is smaller but the other one is not. Okay, so let's write that down. Can there be a case where one condition is true, the other not? Okay, so now we need to go for I from start row to, okay, sorry, this is Python, so in range of start row to start sorry, this is here from start column, right? So for start column to end column, and we need -1, and this needs to be -1 so that we can end at end column. This is because I think Python, to reach end column, we need end column -1 here. Now what do we need to do? We want to return it in spiral order. So what's the format? So the format we want is basically a list of lists, right? Okay, so what we need is to have an output here, so let's just something like that, and here we append okay, so this would be maybe row left to right. Okay, and then we need to append here. We need matrix of I, that's the row. Sorry, this would need to be J because it's for column, and this would be start row, and this would be J. And now we need to increment start row. So our start row will need to be incremented here, and we need to add this to res. So res append this. Okay, so that's the first step. Now the second step is for from end column up to down. So this is, we need to do the i's. So for I in, so this would be column, and this is up to down. And so this would be for range of start row to end row -1. We need to take this, append matrix, and the column would be end column, right? Yes, end column. And we need to have the row I. And then we need to decrement end column, so end column. And then we need to append it. Okay, after that we need end row right to left. So this would be, okay, we go in range of okay, sorry, this is +1 because we are going from start column to end column. So this is +1, and we need end column +1 here to reach end column. And this here is from start row to end row, so it's +1 instead, and we need to do +1 to reach end row. It's only this here because we are going from end column to start column that we need to do -1. And then we need to append matrix at position. So this is for end row, right to left. So this is end row, this is J, and we need to append it at the end with this. After that we have start column down to up. Start column down to up. So that will be so start column down to up. Yeah, so this is column down up, right? And we need to do a for loop, this time for I in range of, this will need to be end row to start row, so end row to start row, -1. Hopefully none of these indices are wrong. And so this will need to append matrix for I, and this would need to be a start column, right? So this is for start column. Yes. And now we need to increment start column. I forgot to do here decrementing end row. And I think that should be it. For the case here where we may get a repetition, so what if start column is still smaller, right? But we don't want to go back, right? So here maybe we need to do I think let's first see if this works, and then we can figure out if there is a problem. So we have index out of range here. So start column and then end column. So this would need to be equal. Because, oh, sorry, smaller, yeah, that's good. So we have index out of range for either matrix or start row. So I think it's start row here. If start row is smaller than rows. Oh, sorry, rows. Yes, that was it. So we have something similar here. So if end row, so we need to do it for end row as well. Is smaller than rows. Okay, so there is still, so that wasn't it. Let's remove it. So this is the row. Yeah, so it's actually bigger than 0. Because we are decrementing it. Do we all increment start row? Yes. Do we increment start column? Oh, okay, so the problem I'm doing it in the for loop here, I need to do it once. All of them, I need to do it just once. And then I need to add also here. I need to append this, and I need to return res as well. Outside of the while loop. Okay, looks like my output is adding empty lists. Okay, so let's make sure we don't add empty lists. And also it needs to be in the same list, not append, so it needs to be extend. Res extend. Let's extend. So extend here. Okay. This should solve the empty list problem. Okay, so that looks good. Okay, looks like we have a problem because I'm re-adding the values. So there is an if check that I need to do here so that we don't go back. So here, if start column is less than columns, and we need to do this here as well, if end column is bigger or equal to 0. Okay, why is this 6 coming back? Okay. Let's try to come up with a test case that replicates the problem. So we know that it's replicated here and not in the other problem. Could it be replicated for all even length? No, it's not. Okay, maybe we can try to simplify this one. What if I just keep it to length 2? Yeah, okay, cool. What if I remove this? Would I still have the problem? Yes, okay, cool. Yep, this is a lot better. So I think maybe we can actually get it with just this. No, okay, so sounds like the smallest one we can have is maybe that one. Can we have it with maybe 2? Okay, no, so yes, looks like the smallest one we can have is this one, and we can try to debug it. Okay, so let's try to debug this. Okay, so now let's just print each one of them and see. Okay, so looks like what we have here is that first it's good. End row is 1 at the start. Yes, okay, 0, 1, that makes sense. Row left to right, we do 1, 2, 3, okay. And then so this matrix is 1, 2, 3, 5, 6, 7. So we do 1, 2, 3, and then down is just 7, that makes sense. And then after that we have, 1 second. And then after that we get right to left, which is 6 and 5, which makes sense. And column down up is nothing, which is good. And then we do the second iteration, and then row left to right has a problem because so start row is bigger than end row. So here if start row is smaller than end row, this is what we want to do. And that should work. Same thing here, we want start column to be smaller than end column. And here, only if start row is less than end row. And here, only if start column is smaller than end column. The rest will be taken care of with the for loop, I think. Okay. Okay, so we have too many prints. Let's move them. Too many prints. Whoa, looks like there's a problem here. We never decrement someplace. It's stuck at start row equal to end row. We'll still do that. We'll still do this. We'll still do this and this. Okay, I think we can just restrict this, and okay, cool. Let's try to submit. Okay, great. That passed this case. Is cool. I wonder if there is a way to do this in a simpler approach. With some sort of a direction that changes. In terms of time complexity, so this is looks at each element only once. So it's, I think, of n by m, with n is the number of rows and m is the number of columns. Okay, so let's think through if we can solve it, if we can improve this a little bit. So we know we have directions, right? Which what we do is each time we do, so here we are increasing the, so we either increase x or y or decrease them. So it would be 0, 1, 0 minus 1 when we decrease, 1, 0, or 0, 1, or minus 1, 0. So what I'm thinking is a loop that does each one depending on the direction. So loop, so loop for each one depending on the direction, right? So yeah, let's try it. So what that would be is, so we'd have this is our directions, and I think we should still have this, but I think we should have maybe x and y, which start as, or I and j. Let's do x and y, which start at 0, 0. and we can do our x is smaller than rows and is between 0 and we need to have current direction, right? So what should be our current direction? 0. So if we do that, then we would increment. So every time to change direction, we would do directions current direction. And then here we would do +1 modulo the length here, which is 4. You could do just 4. We have 4 directions. And how do we know how to loop here? That's a tricky part. So 0, 1 will tell us that we need to increment the columns. Here it will tell us we will need to decrement. The next one will need to tell us that we need to start from row 0 and we need to increment rows. So the second one we need to increment rows. So the first one will tell us we need to, okay, so first is increment columns, which what this will tell us because we'll be adding 1. Second will tell us to this, we start from 0 and we go up, so increment rows, which means we need this to be 1, 0. And then the third would tell us to decrement columns, which would be -1, 0. And then, okay, let me just do like the directions here. And then the last one will tell us to so it's down to up for columns, so decrement for rows, so decrement rows, which means it needs to be -1. Okay, so increment columns, this is good. Increment rows, this is good. Decrement columns is this. Decrement rows is that. Okay. Okay, so now that we have that, we can just follow the direction, right? So I can try to do it. Now if So this would mean we need to increment rows. So this would mean increment rows, which would mean traversing a column. And so it would be so where do we start with columns? Yeah, we'll still end up with all of this. Okay, so if x equal in 1 or minus 1, this would mean else here if y increment is in 1 minus 1 as well. This would be 4j. I'll try next to reduce it to one for loop. So what this would mean is that we would need to okay, so here we want to increment rows. So for I in range of, where do we start? So we need to start somewhere, and this would be x increment. Okay, so problem is we don't know what to do, what to put here. We could have start row. And end row, and that would be 0 and rows minus 1. Let's see if that would, and we would and the problem is sometimes we need to do end row. Okay, so I think this is becoming more complicated. This is equal to 1, otherwise it's end row. It needs to be end row, else it starts row. No, I don't think this simplifies it. So we are trying to simplify it, but this doesn't. So yeah, I think here I could not, I could, instead of using extend, I could just add to res. So I could just add there like this. So res append instead of doing this extend, but yeah, it doesn't matter. Let's see, so Is it same directions? 0, 1, 1, 0, 0 minus 1, 1. Okay, so good. One, it's 0, 0. Case here is that we need to add. Okay, so current direction, let's do row increment or increment. And column increment. Okay. Okay, let me just have column increment. Okay, what is this in steps? And initially, Okay, so I think maybe we can simplify this a little bit. So let's just go until we reach that length, right? And then here, if this is smaller than what we want, which is rows multiplied by columns, we want to add okay, let me start from 0. We want to add matrix xy, and then we want to change direction, right? So next, so current direction is this. Okay, I'm just going to call this D. And we know now that so we are going to check the new x and y once we move in this direction are going to be an x and y which are equal to this and then this. Okay, now we are going to check that those are valid. So smaller than an x and rows and smaller than ny and columns. In that case, I think what we want to do is, if that's the case, then we want to just have x and y equal to that because those are valid. So for the next iteration we'll just add. Now if they are not valid, that means we reached the end of our direction. Basically we reached the boundary here, and so we need to change direction. So that means here we need to change direction, right? So to do that, we just call D is equal to the previous one plus 1. But what if we already did one spiral round, like we reached the end when we need to go again? So we need to do it modulo the length of directions, which is 4, but I'm just going to do directions here. Now next step is going to be, so what about x and y? They will still be x plus, they will still be the same thing, right? So one thing to think about is, what about for the column here? So we would have reached the end of the last column, and that's what we want. But the row needs to be the first row, which in our case here it didn't move, so it's fine to, we'll just increment it by 1, which is the new direction 1 here. So yeah, I think this works. So plus dx, and yeah, I think this would be okay, I think we can do this differently, because in any case we would have an x and n1. Yeah, no, dx, which is d0 here. So we are going to call this d, so we are going to do dx and dy again, because we changed the d, so that's going to be this. I think we can do this here. And this is going to be plus dy, and then here we are going to do dx here, and this is going to be x, and this is going to be plus dy. And then we return res. I wonder if with this we'll have a problem with duplicates. Okay, so this is not an X. Okay, yeah, I would have to check the next state. Okay, so we'd have to keep doing what we had before. So this would be still we would have an X and Y. It's going to be equal to this. Okay, it looks like there is a problem here because the rest is good except this 1 and 5. Okay, let's verify our direction here. So we want to increase columns first, and then after that we want to increase rows. Then after that we want to decrease columns, so that's what this does. And we want to decrease rows, and that's what this does. Okay, so maybe it's okay, I'm going to do something here where just keep track of those that we already seen to avoid errors from there. So here we are going to add X and Y, and here an X and then an Y not in scene, so we haven't explored them yet. Okay, so we can't add a tuple like this. I can just do this. Okay, so we can't add that either. Okay, maybe we need to have an array here, false, and this would need to be for range of columns, and then here for each row. And this would be, oh, okay, so sorry, maybe this was the problem. I had coded it wrong before, so this needs to be seen.
That's compacted.
Okay, so it looks like that passes. Okay, so with seen done properly, that works. Let's submit. Okay, so that passes. Yeah, okay, cool. So another idea that I want to explore here is, what if we extract the first row and then completely remove it from the matrix, and then have just to deal with the rest, which is 4, 5, 6, 7, 8, and then from there 4, 5, 6, 7, 8, and now to be able to get, and then we can try to move 6, 9 to be the first row. So basically each time extract the first row, extract first row, and then transform matrix in a way that what we want for the spiral order is the first row. So to do that, I can just transpose the matrix, right? And now I would have 4, 7, 5, 8, 6 9. Now for me to get 6 9, I can also I need to so transpose first to turn the row into columns, to turn the columns into the rows, and then reverse. And then once I reverse, I would have 6 9, 5 8, and then 4 7. And now we'll just extract first row. Okay, so I can maybe do something like this: res equal to this, and while matrix, right, well, it does have elements, I can extract the first row, which just can be done by 0. So this will be first row. I can extend res with that, and now I can do the rest of the transformation for the next iteration to extract the first row. So to transpose, I can do zip. This will help me transpose the matrix. Okay, let me just call it transpose function. Matrix. Okay. And then I will need to reverse it. So reversed and then transposed. Now I need to define my reversed function, transpose function here. And that is just, we can use just zip matrix. Or the other way to do it is just to do it like in a, we are just turning rows into matrices, so let's do it in a more clear way here. So matrix, and then column, our columns are, this is j and this is 0. And now what I need is just matrix of ij, matrix of ji. We are just going to swap these. So this would be that, and then this would be ji. So we just swap them. And that's pretty much it. But we are not returning, so maybe we could do transpose first in place, and then okay. And then at the end we can return result. The problem is that this is not necessarily okay. Let's return it instead of changing it in place, because changing it in place is harder. We can just do res or yeah, res maybe t, just for transposing matrix. So that would be add 0, have rows, columns, length of matrix, 0. So this in range of columns, and then this in range of rows. And then from there we would need to do this would need to be t. So this would be rows actually, because it's the reverse. This would be columns. And I think I need to close this here. So it's still actually, do I need? Maybe I don't need this. Yeah, I didn't return t. This would need to be moved back to list. Okay, we need if not matrix, return just the same thing. If it's empty, return the same thing. Okay. Does this work? Okay, looks like it worked. Awesome. And we keep extracting until we get the empty list. Yeah, so a better way to do transpose is to just okay, let me show this maybe in Python here. So this is our matrix. If we zip it, we get, you can see we get the matrix is already 147. It's already transposed 258. So 258 and then 369. So that already does the does it for us. So zip basically will zip each. What zip will do is we'll take each element from the list, zip it with the other one. So we'd have one. We'll zip the elements at the same index for each list, and so that would be 147,258, and you get the idea. So that's why it works. So instead of doing this whole thing here, we could just return zip matrix. We can return this, and so we could just actually put it here, or yeah, let's do it like this. We can put it here. That would be simpler. So that would be the transpose. Now for reversing, so let's call this T. For reversing, we could just do this instead of reverse it. So we could do, take that and reverse it, and we would have this. Maybe we don't need. Yeah, we need to turn it into a list and then reverse it. So we turn it into a list and then reverse it. And that still works. Now we don't need this transpose function. We can also, we are not using first row here, so we can just use matrix.pop0. And that still works. The other thing is we could probably do a recursive function instead of a while loop here. So how can we do that? So we can just think about maybe doing something like so we're gonna definitely call spiral order with the new matrix. So that will be this, right? Okay, let's call it a new matrix. Okay, past that. Now we need to add the first row. So that will be first row. And then we need to add that. So first row plus, and we can return. However, we need to have a base case. So if not matrix, we're going to return empty list. The problem is that this is a tuple. So what we want is here, we want to do list x for x in this, because the zip here turns it into a tuple, and so we want Can zip be past the parameter? So Python zip. No, it can just be past the iterable. Well, we can have this, and then take the new matrix, return it, and then if we run, okay, so why is this? Okay, let's try. So we have our matrix still. Okay. Now if we zip, if we do this, we do have the right thing. Yeah, maybe it's because it's I'm using Python Python 3 here. However, this is Python 2. Okay, let's print zip here. Let's do this. Okay, and let's print it just to see why it has a problem. Okay, so that's why we could definitely turn it into a list here. Okay, and this should. Okay, so that works. So what I need is either that or I could just use reversed here instead of this -1. Okay, still has the same problem. Okay. Okay, so now with this, we are using a recursive function. We submit. It works. Okay, so we can also okay, let's put this back here. And we pass that. So we can pass this here, and here we can just do this since it's the first thing. And we run it. Okay, so that passes as well. Let's submit. And now I think since we are doing just not, we can just do and. So if this is true, then we will run this. If it's not, then we'll just return it. So if we run this, okay, I need to get rid of the base case here. And we can submit, still passes. Yeah, this is just for fun, but yeah, this is harder to read, so ideally we shouldn't do it. Maybe we can get rid of this. Let's see if we can get rid of this. Yeah, we can't. Okay. Yeah, I think this is good enough. Yeah, so that's pretty much it for this problem. Thanks for watching and see you in the next one. Bye.